question. So what do you think is the minimum number of people in the group so that two people definitely share the same birthday? Yeah, maybe which is a very nice, a mind-bending concept. In fact, the first time I studied this theorem, which is about to come up, it really bent my mind. So what we'll talk about is what is called the Base Theorem. So at least some of us would have heard someone say that whenever the match is tense, Sachin fails. He really should learn to control his tension. Right? That's something like which many of us would have heard someone or the other talk about this, like, to talk about Sachin. Right? Now, is this correct, or is the other question correct? When Sachin fails, the match is tense. Right? So the question is, are both of these the same? Right? So you see, have you seen a ranking for fielders? Is there someone who, I mean, there are people like John T. Rhodes and maybe say Ravindra Jadeja who are fantastic fielders, but do they really appear on any ranking? That's sad, right? Fielders are a very essential part of the game, right? But why isn't there any ranking for fielders? Can we not design one? This genius, Percy Diaconus being the man he is, what he did is something which is like ridiculous. Okay? He took a dental floss and tied it around the coin. Okay? Now you toss the coin. Okay? The dental floss is here. You toss the coin. Okay? The number of times it turns in the air, you can simply count it by unraveling the dental floss. Right? It's a tedious process, but it works. Right? Like 20 rupees, I can get one pack of dental floss and carry out the same experiment. Right? What a genius of an idea this is. Right? And it's indeed an honor for me to give a talk as part of Roots. So ever since I found out about Roots, I must say, so any person who approaches me saying they like math, the very first question I ask is, do you know about RAM? And that's the kind of image that really RAM and Roots have given to everyone. So this is something like which I'm extremely proud of to be giving a talk here. So thanks very much again for the opportunity. And so like Vinay said, so what I will attempt today is to give you a small insight into what is called probability theory and many other surrounding areas. So I'll not be answering questions, but the majority of the talk will be towards, can you ask more questions, right? So my talk, if you see, it'll be more of asking questions than answering them, right? So it'll become clear as we go along. And needless to say, anytime you have any questions, just feel free to unmute and ask. And I do not intend to complete all of the slides I have planned today. So if so, whatever I plan, that should be engaging and entertaining to everyone. That's my only agenda for the day. And feel free to turn your videos on and keep yourself unmuted, and let's begin. So Vinay, can you just...
Sorry, before you start, let me just enable the option for everybody to unmute themselves. So you will have to unmute yourself. You'll go on mute once. Yeah, there you go. You can unmute and start. You need to unmute, Aniruddhan.
Oh, yeah. So, and chat is not extremely handy to me. So you may have to just unmute yourself, or maybe like Vinay, if you can voice the questions on chat, that would be ideal. Okay, great. So let's begin. So the talk I've titled From Sport to Code. So what I intend to do is to give you an overview of how math shows up in the most unexpected of places, like I said in my abstract. So what I'll do is I'll divide the talk into 5 sections. So the first section is maybe like if you want some problems to think about very early on, and you can keep these in the back of your head while the talk is progressing. I do not intend to give the solutions to this today, but if you manage to come up with a solution, do write to me, and I'd love to hear your solution. And so the sections 2, 3, 4, 5 are disjoint from each other. So even if you lose me in one of the sections, you'll very much still be able to catch me back up on the next. Right? So let's begin. So first, let's start with a few zoners. So just keep these problems on the back of your head, and let's see. So you go to a casino, and in a casino, so you bet on the outcome of a fair coin. A fair coin, remember, has 2 outcomes: heads or it can be tails. Right? The amount you bet for is your choice; it's at your discretion, and you can place any number of bets in succession. If you want, you can place a series of 27 bets. You can place a series of 53 bets. Right? And now the question is there a strategy you can use? Will you choose your amount so very wisely that you can definitely make money with this, right? Is there a strategy that you can use so that you can definitely make money? Okay, so that's the first question. And the second question is not entirely related to probability, but this is something which I found extremely fascinating the first time I saw this result. The question goes as follows. So consider the Earth's equator. The question is, does there necessarily exist a pair of diametrically opposite points on the Earth's equator that have the exact same temperature? So remember here, we're asking two things. One is the points must be diametrically opposite. And the second thing we're asking for is that they must have the exact same temperature, right? So if one of the conditions is removed, then it becomes rather easy, right? For example, does there exist a pair of diametrical opposite points? Yes. And does there exist 2 points with the exact same temperature? Yes, I would presume so. The Earth is very large, right? So these two together, does there exist something? Yes, Anushka, question?
It's not a question. I would, for the second one, I have an idea. Should I send it in the chat or should I like unmute
Oh,
it?
preferably not. Maybe we can take this towards the end, maybe? What do you think? Okay,
yeah.
great.
I just had an idea because that may head towards the solution.
Okay.
So would it be preferable to send it in the chat for now?
Okay, so maybe send it to me on private chat, but maybe let's
Yeah.
give others also the chance to maybe like come up with their own innovative ideas. Okay.
All right.
That's
Yeah.
great. Okay, so now let's moving on to the first section of the day. So let's do some warm-up exercises before we get into the sports and quotes part of the talk. So let's start off with what is called the banana paradox. Okay, so the setting is the following: a friend of yours and you have been stranded on an island. Okay, and being the crazy people you are, you have two fair dice with you, right? And there is only one banana as a food resource. Okay, and now you come up with this and say you roll the two die together. If the biggest number among the rolls of the two dice is 1, 2, 3, or 4, then you offer your friend the banana. And if the biggest number is 5 or 6, then you say, let me take it, right? So now the question is the following: are you being generous or are you being smart? So by generous, what I mean is, will your friend get the banana with higher probability, whatever that means, or will I get the banana, which is am I smart? So Vinay, if you could launch the poll here, it would be nice. So any answers? I don't hear you, Vinay.
Yeah, sorry, my connection dropped. Shall I launch the poll?
Yes, please. The first question.
Do you want to repeat the question just once again, Aniruddhan, just for the sake
Sure,
of clarity?
I'll do that. So there are two people on an island and you have two fair dice. So what you say is, if the maximum of the two dice, the rolls of the two dice is 1, 2, 3, or 4, then you offer your friend the banana. And if the maximum is 5 or 6, then you say you yourself will take it. So the question is, are you being generous or are you being smart? Smart is you'll get the banana yourself, or generous is, are you will they get the banana? Oh, the poll's going very good. So maybe like 10-15 more seconds and we can call it a close. Okay, that's great. It's been a minute. Okay, so now maybe that's one. Any of you want to volunteer to explain why they opted for generous and why they opted for smart? Yeah, Anushka.
I think they're smart because when you throw a dice, even though the probability of one disclaimer before I say this. This is from my experience in playing board games. So when I'm playing board games, I usually end up throwing 3 or 4, or usually some of the small numbers that will be there, because in this situation also 4 of the numbers are rather small compared to the other two. And as I was saying, it's more likely if you throw a 5 or a 6, it's more likely that the 5 or the 6 will be bigger than the other numbers. So I think they're being smart.
Okay, that's a good answer. And Anandi?
I think it is generous because most of the time when I play a board game, I get threes and fours, and that's the most we get. So when we add them up, then we get the most number than rather getting a 5 or a 6.
Okay, that's a good explanation. Okay, and I see Adrit and Shashwat have also raised their hands, so there'll be many other polls. So maybe like we'll take 2 at a time. Okay, so the next polls will go to Adrit and Shashwat. Okay, so let's. So I claim that you're in fact smart. Not that you're not generous, but you're in fact smart. Why do I say that? Because so let's consider, what are we doing? We're rolling 2 dice, right? So what are the set of all possible outcomes? The possible outcomes are 1, 1, 1, 2, 1, 3, all the way up to 6, 6. Correct? Now, among these, how many of them have a maximum of 1, 2, 3, or 4? Only 16 of them. Correct? But how many of them have a maximum of 5 or 6? There are 20 of them. Right? So, if you just throw 2 dice at random, then there's a 20 in 36 chance that the maximum will be 5 or 6. But there's only a 16 in 36 chance that the maximum will be 1 or 4. Right? Now, this kind of also explains why I called it a paradox. Why did I call it a paradox in the first place? Because this 1, 2, 3, or 4 seems to be like, there are 4 numbers. So that should be like a very large one. Right? But and 5 or 6 is only 2 numbers and it should be smaller. But what we in fact get is something which is totally the opposite of it. Right? So this is how in fact like math can really fool you. Right? So you have to be very much on the lookout to see how you have to very much think about whatever is going on, and only then can one come to a conclusion. Right? So let's move on to the next one. So it'll just be a collection of discrete examples. Right? So okay, have any of you seen this photo?
Yes, of course we can, because everybody knows aeroplane, right?
Okay, that's good. Okay, this is an aeroplane. And is there anything special about this particular photo?
Yes, it has some red dots.
Yeah, it has dots.
Yeah, I don't really know what the red dots have to do, but I'm sure it's a fighter plane or something.
I know what the dots are, but I'm not going to tell the.
Okay. Okay. And someone said fighter plane. That's where we're heading to. Okay. So I'll just break the suspense. So as someone said, fighter plane. So, this is set in World War II. Okay. So USA and Germany, what they were doing is they were independently trying to study the amount of damage on the planes which were returning from the mission. Right. And their objective was to identify which parts of the plane to strengthen. And so naturally, like a natural choice would be to strengthen the entire plane, right? From head to tail, to strengthen all of it. But that's going to increase your costs, and you do not want that to happen, right? So what you will do is you'll identify the quote unquote weakest parts of the plane, or the most vulnerable parts of the plane, and choose that to strengthen it, right? So now, but the problem is, since USA and Germany studied it independently, their statisticians came up with the exact opposite recommendation, right? So USA said add armor that is strengthen the most hit areas, and Germany said add armor to the least hit areas, right? So now again, I ask the same question: which of these two makes more sense? And Vinay, the poll again. So recall again, USA said add armor to the most hit areas, and Germany said add armor to the least hit areas.
Is the poll visible?
Yes, yes.
Okay.
Mr.
May I ask a question?
Sure.
What is an armor?
Oh, just think of armoring as strengthening the plane, where you're adding some additional, I don't know, like additional metal to shield itself from bullets. Okay. Yeah. Okay, this is good. Maybe like 10-15 more seconds. The answers are in a good ratio again.
And after that, do you want to share the results?
Yeah, sure. This poll, the outcome is good. So yes. Okay, this is good. I think we can call it a close. So once again, so maybe does anyone want to explain why they said USA is the correct answer? Okay, Hamini. I'm not sure if I pronounced your name correctly.
Himani.
Oh, Himani. Sorry. Yes.
Yes, sir. So
Yeah.
I think USA's recommendation makes more sense because adding armor to the most hit areas were protected.
Okay. That's a good answer. Yes. Adding armor to the most hit areas is going to shield it from so the place which is taking the most number of hits, right? That's a good answer. And what about maybe say A3? Do you go with USA as well, or is there someone who goes with Germany?
I go with USA
I
as well.
go with Germany. That's
Oh, okay. 1 second. Someone had a question. Who was that?
Sorry, I'm Ashmata. I
Yeah,
just
sure.
want to ask that I answered the poll, but
Okay.
it's coming that I didn't answer the poll.
Vinay, I'm not sure how to handle this.
No, I think we can just not worry about it. Maybe some Zoom glitch. Yeah.
Yeah. Okay. And, right. So anyone in favor of Germany?
Yes, Shashwat.
Okay. Yes, Shashwat, go on. I like your enthusiasm.
Strengthening the weaker parts would mean that you are giving a kind of protection to the parts which are hit more.
Right. Okay. And does that wait? I'm not sure if I understood you entirely. So the question I'm asking is, does it make sense to add armor to the least hit areas?
I think it does because if you add armor to the least hit area, then it would actually mean that it would strengthen the rest of the part.
Okay, that's a good answer. Okay, I take that answer. Yes. Maybe Ridhima, do you want to give another attempt?
Yes, sir. So what happens that if you strengthen, ma'am, so they're the hit parts, and if ma'am that parts are still there, means that parts are strong. So you have to. So I'll go with Germany because then you have to strengthen the least hit areas.
Amazing answer. That's a fantastic answer. So the idea is, as again Ridhima pointed out, some planes did not return, right? That is something which we have always excluded. So this is something what is called sampling bias, right? But let's not get into all these technical jargon at the moment. But what is going on here? Let's go back to the picture. So if someone fires a bullet at the engine, right? It's almost certainly going to go down, right? But the problem here, the picture shows the number of bullets each part of the plane has taken, right? So if someone fires a bullet at the engine, so then what's going on is, this is saying that the plane has not returned at all, right? So what you should rather do is to strengthen those parts of the plane where there have been no hits, because the parts of the plane which have no hits, what it could possibly mean is that the plane took a hit to that and it never came back. Remember what I said again. I said they were independently trying to study which were returning from a mission, right? They were studying the planes that returned. They did not study the planes. They could not study the planes that did not return, right? So you should convince yourself now that since the planes did not return, it definitely does make sense to add armor to the least hit areas and not to the most hit areas. Okay. Yeah. Any questions, Shashwat or Ashmita?
Sir, I don't understand that.
Yeah. Okay. So what I was trying to say is, okay. What I was saying is, what are we studying? We're studying only the planes that returned from the mission. Okay? Now, since we're studying only the planes that returned from the mission, we're excluding the whole bunch of planes that did not return at all. Right? That's something which have taken completely out of our
Yeah.
picture. And why did they not return? Because they may have been hit in a very vulnerable area. Right? For example, if they were hit in the engine, there is a slightly lower chance that they would have returned. Right? So it does make sense to strengthen the least hit area. Right? Okay. So moving on to the next one. Okay, so I'd like all of you to type your date and month of birth in the chat. So just put it, don't write it as 0910, maybe say 9th October or something, just to avoid confusion.
I had a small question about the last
Sure.
problem. Did it actually happen? Like, was this something in real life?
Yes. I think Andrew Wald or something is the name of the German statistician who came up with this.
Okay, so this was something that happened in real life during World War II.
Yes.
Thank you.
Okay. So does someone want? Okay. Are there? Okay. I am. Okay. It's an. Oh, I see 22nd December's already. Oh, interesting. Ridhima and Ananya. Okay, great. So that's good. So Vinay, if you see other people who share the same birthday, let me know. And anyone today?
Sir, there's 226 numbers, sir, including me.
Awesome. That's nice. Okay. So this is something like which is extremely fascinating. The first time I saw it, like I was really puzzled. Right. So what do you think is the minimum number of people that are necessary in a group so that there is a sure shot that two people have the same birthday? Any guesses?
So may I say? Do you want to just repeat the question and maybe ask if people already know this, then maybe they can.
Okay, sure.
Not
if you've seen any of this, like please don't spoil the fun. But
I have actually seen something like this, but I don't really remember most of the stuff about it.
Okay,
I don't remember the answer, and I also don't remember how the answer was found.
Okay, that passes as good enough. That's okay. So coming back to the question. So what do you think is the minimum number of people in the group so that two people definitely share the same birthday? Yeah, maybe. Yeah.
May I say so?
Sure.
Okay. So the definitive number of people should be 367.
And because why is that?
Because in a leap year there are 366. Are we including leap years?
Yes, let's throw that also in.
Okay then. In a leap year there are 366 days, and so in a scenario that's not very likely, but it could still happen. In a group of 366 people, each person has exactly one. Each person has a completely different birthday. But if you have 367 people, there is a definitive chance that the 367th person would have the same birthday as one of the other 366 people.
Excellent answer. That's an excellent answer. Right. So this is in fact what is called the pigeonhole principle. Right. So what this is saying is that say you have 10 pigeons and only 9 boxes. Okay. So then there must exist at least one box which has at least 2 pigeons. So remember, there are 2 uses of at least here. I'll just repeat the statement again. If you have 10 pigeons and 9 boxes, there is at least one box which has at least 9 pigeons. Right. So we use the exact same scenario again. Right. There are a total of 366 different days on which a person could be born. Right. And if there are 367 people, then there must be at least one day in which 2 people are born. Right. So this gives a good answer. Right. So 367 is the correct answer. Now I'll tweak the question a teeny tiny bit. What do you think is the minimum number of people so that there's at least a 50% chance that 2 people share the same birthday, right? So for now, let's just ignore leap years. So let's just assume that all years have 365 days, and let's not consider the possibility of twins and all that, right? That'll add to the confusion. Let's just start with the simplest model to work with, right? So in other words, what I'm asking is how large should a group be? So what's the minimum number of people in a group so that it's more likely than not that 2 people have the same birthday? Okay, so I'd really like if people who did not see this problem before who can maybe give it an attempt. Okay, any new hands? Okay, Himani, I see your hand.
Yes. So I had read somewhere, don't know where, but in a magazine or something, and it was written, I think, 23, because it makes in a group of people which has 23 people. So there is a 50-50 chance of the people having the same birthday.
Okay, okay. And maybe Shashwat, do you want to give an attempt?
It should be 163 as the last. I mean, there are actually, yeah. There are 365 days. 365 by 2 is 182.5, and when that is rounded off, that gives us what do you say, 183. So
okay. Now a question for you. Okay, so you're saying that your idea is the following, right? If there's a 100% chance, then 367, and if we are not counting leap years, then if there's a 100% chance, then 366. If it's a 50% chance, then 183, right? That's your idea, correct?
Yeah.
Okay, great. So now, why does it have to be? This is what is called a linear function. Okay, the question is it linear, right? And turns out that it's not linear, right? And the 163, 183 is in fact a very common answer to this question, right? And with 183, like you can expect. So I mean, like even here, I think like with a couple of dozen people, where we have like I think 2 pairs of people who have the same birthday, right? And here 183, there is a good amount of chance that you will have 2 people with the same birthday, but the answer is in fact 23, right? Let's come to why it is. Before that, what do you think? If there are 50 people, what are the chances that 2 people have the same birthday? Or if there are 75 people, what are the chances that 2 people have the same birthday? So keep these questions on the back of your head, and in the meantime, we'll see why it is 23. Okay. Now, so let's consider a group of 23 people. Okay. Now, the first person can have their birthday in any of these 365 days. Correct? The second person can have their birthday in any of these 365 days except the very first day, right? So there are 364 days when the second person can have their birthday. Similarly, the 23rd person can have their birthday in any of these 365 days except those that were taken by the initial 22 people, correct? Now, if I just divide each of them by 365 so that it's bounded within one end, like I get a probability, what I in fact am computing is the chance that no 2 people share the same birthday, right? So if I do that, what I'm getting is this number itself is around 0.49, right? That is, the chance that no 2 people have the same birthday is less than 50%, right? Now, if I just turn this around, if I just complement it everywhere, right? Formally speaking, what I'll get is the chance that there is at least 2 people who share the same birthday is 1 minus the 0.49, which is a 0.51, which is greater than 50%, right? So what this is saying is that even in a group of 23 people, there is around a 51% chance that there exist 2 people who share the same birthday, right? This is really mind-bending stuff, right? So in fact, if there were n people, you would extend this all the way down to 365 minus n plus 1 or something like that, right? And if you try to plot what the graph is going to be, this is how it is going to look like, right? So if you can see here, the 50% mark is somewhere between 20 and 30. It's closer to 20, right? This is 23. Now, answering the questions which we had back there, if there are 50 people, what is going to happen? If there are 50 people, look at this. It's coming to somewhere around 95%, right? What is it saying? I have a group of 50 people, right? Then there's a 95% chance that there are 2 people who share the same birthday. And that is very much well verified in this group itself, right? And let's say 75 people, right? If there are 75 people, there's almost a 99% chance that 2 people share the same birthday, right? So this is something which is like, which is really unintuitive to start with, right? But the more you get the hang of it, this is something like which will become eventually clear. And I really liked the answer who said 183. And that's a very common answer because the brain really struggles to process anything other than linear functions. So if something is increasing linearly, yes, we like it. My life is set. But the moment exponential functions enter, the way it grows is something which the brain really struggles to process intuitively, right? So that's the main reason why the 0.49, which is 23 people, you get a probability of 0.49 of no two people having the same birthday, right? Yeah, Atri, you've raised your hand.
Yeah, I don't really understand why you put the last fraction as 343 by 365.
Okay, sure. So let's see. So the first person is 1 in 365. This you agree? Just keep yourself unmuted. Let's just sort it out.
Yeah, I understand the 365, 364 and so on thing. But why does it end in 343?
Okay, it ends in 343 because I'm taking only 23 people. So for instance, had I taken 5 people, okay, so it'll be 365.
You repeated the answer and you're showing why.
Yes.
Okay.
Yes. Okay. And Siri, a question?
So I didn't understand how you got 0.49.
Oh, this is just multiplication.
Calculator. Sir, I couldn't understand what you're saying. So can you just repeat it again?
Oh, definitely. Yes. Thanks for the question. So what I was saying is that let's consider a group of 23 people. Okay. The chance that no two people have the same birthday is, in fact, what I'll do is I'll just try to do a simple combinatorial approach to this. Okay. So the first person can be born on any of the 365 days, right? The second person can be born on any of the 364 remaining days, right? The third person can be born on any of the remaining 363 days, right? And if I extend it all the way down to 23, the 23rd person can be born on any of the remaining 343 days, right? Now, if I to compute probabilities, what I'll do, I'll just divide throughout by 365. And if I multiply everything, I'm getting a 0.49, right? So what have I computed? I've computed the chance that no two people share the same birthday is in fact 0.49, right? So now if I want the probability that there exists at least two people who share the same birthday, I'll simply take the difference of this from the whole sample, right? Which is 1 minus of this, and I get a 51%, right? So the chance that there, at least two people share the same birthday in a group of 23 itself jumps up to as high as 51%, right? So let's see a live example of this. So just consider the 28 chief ministers of the states of India. Okay. Now, turns out Nitish Kumar of Bihar and M.K. Stalin of Tamil Nadu have the same birthday. Right? This is something which works out very well even in a group as small as 28. Right? So this is something like which is really a very live example of what's going on. Right? Okay. Now let's come to something which I think I've been waiting for. So how cricket is just math is just everywhere in cricket, right? And how you can in fact use a lot of math to make cricket a better game. That these are some questions which we will ask. So throughout the section, I'll not be answering questions, but I'll just make you think that there are so many questions that you can ask if you just try to impose, just to intersect math and cricket, right? So let's start with this. So does anyone want to take give a go? So if we try to use math in cricket, so what are some possible questions which can crop up? What are some possible questions we can answer if we try to put all the math we know in cricket?
Addition.
Okay, and maybe Shyam Madhav.
Sir, addition can be used.
Okay, and how will you use addition?
Possibility.
If you hit a 6 or something at the end, all of them are supposed to be counted.
That's good. That's good. To calculate the total score, say a team, what the total score of the team is, or what the total score of individual batter is, and all these we can use addition. Okay. Then what else can we?
Also.
Okay, where do we use multiplication?
Multiplication, how much ever 6 is, then after at the
good.
end.
Okay, that's good. Making our life easier to compute the scoreboard, we can use multiplication. Yes, Kirti?
We can try to find the possibility of number of sixes that can be hit in over.
Awesome, that's good. That's a lot into probability again. I like that. Next, Arhant.
We have to calculate the average and economy and cricket of bowlers and batters, so we use math.
Very good. Mean is something. Mean is a very good answer, and maybe I'll just take one or two more answers, and maybe let's. Okay.
Can I tell?
Yeah, sure, shoot.
We can use because the cricket ball, when it's thrown, it travels in a series of parabolas. So maybe we can use conics.
Nice. I like that answer. That's good.
Yeah, and we can also use game theory because in IPL teams buy players, so we can find out the strategy to buy good players at a certain cost.
Fantastic answer. That's what enters into this whole thing about auctions, right?
So
yeah, sure, Siri.
Yeah, comparison of the net run rate.
Good, very good. Comparison of net run rate. Good, Vaishna. Are you around? Okay.
Vaishant.
Oh, Vaishant. Sorry. Okay, I should really learn English back again. Okay. So all right. So very, very good answers came up, right? Let's see. Let's put in more questions into the table, right? Is there a better DLS method? What's a DLS method? Say a game has been washed out by rain. Okay. So let's say there's a very exciting India versus Pakistan match going around. Okay. India scored like some 330
sir,
runs.
What is the full form of DLS?
Oh, DLS stands for Duckworth-Lewis-Stern method. But I'll elaborate a little bit more on it a bit later. Okay. So let's say we have a very exciting India versus Pakistan game going around. Okay. The ODI match, let's say India scored 330 runs. And Pakistan scored 100 for 7 or something. Okay. So this is like a very sure shot for India. But as luck would have it, it starts raining. Okay. So now we need to be able to compute. The rain, say it's predicted to be cleared in maybe like say 30 minutes or so, but the match is restricted. That is, the entirety of the match cannot go on, but say only 5 more overs can go on, right? Remember, India 330, so target for Pakistan is 331, and Pakistan are currently on 110 for 7, right? So now, if someone sets a target of say 130 runs in an additional of say 5 overs, right, then it may not be very difficult for Pakistan to win, correct? So we need to be able to come up with a very nice score to set up so that both the teams are happy, right? So can we do something about the DLS method? Next, this is something like which ICC has always been doing. So you'll see like these regular rankings released out, right? So Virat Kohli, Kane Williamson, they occupy the top, and there are like many others who follow, right? So how do we rank players, and is there a better strategy we can use to rank players? What all goes into deciding where the rank of the player what the rank of the player should be, right? Similarly, you'll see teams like you'll say something like India is always the number 1 in tests, right? But what exactly do you mean by India is number 1 in tests? And if there is a particular strategy which ICC uses, can we use a better strategy to rank the teams, right? Similarly, and as someone pointed out, auctions, right? A better auction strategy for IPL teams. So for this, bug your very own veteran. Adityan Ganesh is a RAM veteran. So bug him into giving a talk for this entire theory about auctions and game theory and a lot of it. Okay. And I see a couple of raised hands. Yeah, Himani? Sure.
So I had an idea for ranking teams. I don't know whether this idea is only used because I don't know much about cricket. So we can take out the annual range of all the teams, and the team which has the highest annual range can be ranked at the first.
Good answer. That's a good answer. Definitely a good answer. So we'll see like how more we can maybe like, is there a way to improve it? Is the existing one good? And these are some questions which we'll answer. Yeah, Preeti.
So can I say?
Yeah, maybe we will discuss the answers about like we'll ask more questions about how we can rank players. But in the meantime, if there are any questions, then maybe I'd like to take them. Maybe Preeti. Yeah, any questions?
No, I had an answer for the second question. Can we rank players better?
Okay, maybe we'll take that in a minute. Is that fine?
Okay.
Yeah, great. And Ashmita? I hope I've pronounced your name correctly at least. But...
Yes, sir, you have pronounced my name correct.
Okay, great.
I was just telling that I have the answer for number 3. Can we rank teams better?
Okay.
So for that,
Okay, we'll take that in a minute, maybe. Is that okay?
Okay,
great. Okay. Let's see. Okay, so keep these questions on the back of your head. So what can we do to assign a better DLS par score? And are there any ways we can rank players better? Are there any ways we can rank teams better? And finally, can we use a better auction strategy? Right. So now, do any of you recognize this picture? So our grandparents would have been teeny tiny kids when this happened, but any guesses as to what this picture is?
The first game of cricket?
No, it's not that old.
Somebody said Sunil Gavaskar in the chat.
Okay, no, not Sunil Gavaskar. Yes, Don Bradman 0. Yes.
Is it body line, sir?
Oh no. This is Don Bradman's final inning. So this is what happened, right? So this was Don Bradman's 70th and final innings. So far he had an aggregate of 6,996 runs. So had he scored 4 more runs in the final inning, he would have gone in history as the batsman to have a 100 test average, right? But as luck would have it, he got his bails dislodged for a golden duck. And so history has been written that his average is 99.94. Right, so this is one very, very, very memorable moment for any cricket fan we have here, right? So I just put this in. This really has no bearings on what we'll do later or what we did earlier, but this is something which I found really fascinating. And since the talk about averages came up, and so So now this is something. So now we'll introduce something like which is a very nice, a mind-bending concept. In fact, the first time I studied this theorem, which is about to come up, it really bent my mind. So what we'll talk about is what is called the Base Theorem. Some of you may have heard of it, some of you may not have heard of it, but so the idea is the following. So at least some of us would have heard someone say that whenever the match is tense, Sachin fails. He really should learn to control his tension. Right? That's something like which many of us would have heard someone or the other talk about this, like to talk about Sachin. Right? Now, Sachin is Sachin Tendulkar, in case you're not at all a cricket fan. Okay. Now, is this correct, or is the other question correct? When Sachin fails, the match is tense. Right? So the question is, are both of these the same? Right? So you see a difference, right? When the match is tense, Sachin fails. When Sachin fails, the match is tense. This naturally makes a little bit more sense, right? Because Sachin failed, the match is tense. That is some sense what this is implying. But this is kind of implying that Sachin is not good under pressure, right? But I would really tend to go with this statement. That is, when Sachin fails, the match is tense, right? What we're trying to say is that these statements are very much different from each other, right? Yeah. So what we're trying to say is like this is an exposition into what is called a Base Theorem, right? So let's just take A to B, like set the all matches when Sachin fails, okay? That is, he got out on a duck or he got out in a single digit score. Okay. Ashmita, if you're trying to say something, you're muted. I can't hear you. Okay. So and let A be the set of all matches where Sachin fails, and let B be the set of all tense matches, right? Let's say like 15 runs required in 1 over, like it happened in the RCB versus Delhi Capitals match yesterday. So now what this is saying is that, so this notation A given B, so you read this as A given B. What this means is that if the match is tense, then what is the chance that Sachin fails, right? So this talks about if Sachin fails, what is the chance that the match is tense, right? So this Base theorem very nicely captures how these two events relate to each other, right? So from here, so I'll not get into the proof of this theorem and all that, right? That is something which is left for the proper math course, right? But what I'm trying to do is to just convince you that these two events are in fact very much different, right? So, right. So this is something like yes.
Sir, I cannot understand this question.
Okay, sure. So okay, so what this is saying is that okay, so you or maybe your parents would have definitely heard the statement that if the match is tense, that is like if it's in a very critical situation, right, then Sachin will not deliver as much as he would, right? But what I'm saying is, if Sachin fails, the match will be tense. Something like that is what I'm saying, right? Now, what I'm saying is that the two statements are different from each other, right? That is all I want to convey. I don't want to get into any of these like too much of a technical detail, but like all what I'm saying is to convince yourself that the two statements are in fact different from each other. Okay. Yeah, Anushka.
I had a question about the base theorem statement. Is that vertical line supposed to be divisible by, or
No. It means given. That is the event to the right of it means that is something which is given to you, right? So A given B means that you're given that the match is tense. Now, can you compute what is the chance that Sachin will fail? Right?
Okay.
B given A means that it's given. You're told that Sachin has failed in that match. Now, can you compute what the chance will be that the match is going to be tense? Right? The match is going to be critical. Right? So what I'm trying to say is that these two quantities, A given B and B given A, are in fact two very different quantities. Right? And it is very common nature to mix all of these up and create a whole load of mess because of this. And particularly so in the COVID situation. That is the vaccine working or not, and all these, like there are all sorts of questions which come up, and this is something like which I think I'll maybe like give it a quick skip. Okay, so I'll give this a quick
so that
skip.
basically means implies.
Yes, you can think of it that way. Yeah.
Okay.
I'll give a quick skip to this, and maybe like if there's time at the end, we'll come back to this. Okay, and so now coming back to the more interesting question. So how do we rank teams? How do we rank?
Was this the moral of the story was get vaccinated?
Oh,
right,
no, that's the part I skipped. I'll come back to that maybe towards the end.
Yes, sir.
Okay. So now let's come back to the question of how we should rank teams. Okay. So some of you said that you had answered. So now I'm posing another question. The question is, what are some factors that you should take in to say which team is the best? Okay, so I hope the question is clear. Yeah, Siri, I see your hand raised.
Yes, so first, if
sir, I can
if you're taking,
one sec. Siri, yeah, go on.
Yeah, so if you're doing it in IPL, you should consider the points.
Okay.
And for other matches, you can consider how many matches they have won.
Fantastic.
And how well they've won.
Fantastic answer. That's good. Hari?
Sir, I'm Akshay, sir. Sir,
yes, sir, Akshay, go on. Yeah, Akshay, go on.
He's on mute. So maybe those who wish to say something, those who wish to say something maybe can do a raise hand and wait in turn.
Yes.
Meanwhile,
sir, I get my hand raised.
Yeah. Kirti was asking if you can repeat the question.
Yeah. Okay. Sure. So the question is, so when you want to rank teams, okay. So say ICC releases out these rankings, right? So India is the best team, then comes some other team, then comes some other team, then comes some other team. So what really does ICC do? Do they roll a die and say, oh, the top of the roll is 3, and so India is the best team? And next they roll another die and it's say 5, and then say, I don't know, New Zealand is the best team. Do they do that, or do they take a more rational approach to this? That's the question. And if they take a rational approach, then what all factors do they consider? What all factors should you consider if you were to rank teams? How would you rank teams? Okay, maybe Harish. Are you around?
Yeah, sir. The factors you should take into consideration will be the overall win percentage, how many matches that they have won, also the individual rating of the players themselves, because that will
Debatable. Okay.
that will predict that the team will do better in other matches. They have a good better players.
That's
So
good. Okay. Good answer. And
these two things are the what I think that should be taken into consideration.
good answer. Okay. And Pratyay, and maybe start with how to pronounce your name and then maybe go to the answer.
Okay, so my name is Prachai.
Oh, yeah. Okay.
So the factor which can be taken to decide what the current best team is, like we can measure how many runs is scored per over.
That's okay. Okay. That's good. Okay. And maybe, okay, so I see many raised hands. So maybe just type out whatever you think should be considered. Type it out in the chat.
Sir, can I say, sir?
Okay, we'll just take one more. Yeah, you go on and maybe others just type it out in the chat. Yeah.
Yes, sir. Sir, when a match is won, so they will say it is not the best till. They win many matches, so they will take this team is the best in cricket.
Okay. Okay,
Right,
that's a good answer. Yes, that's a really good answer. Okay, and
Yes.
okay, so yeah.
Could I just add one more point?
Yes, sure.
The winning score of each ground,
Very
the
good.
score differs from ground to ground.
Very good.
So we have to take the average winning score in each ground to measure.
Excellent answer. That's a very good answer, right?
So Janardhan Krasnarayan first told in the chat. So.
Okay, that's good. That's good. These are very good suggestions which are coming up. Okay, so let's save the chat and maybe like recommend to ICC saying why don't you do this also. Okay, very nice answers coming up. So let's write a mail to ICC today. Okay, so first thing is we need to win. Yeah.
I think there is some sort of algorithm for ranking this, because I play chess and FIDE uses this algorithm called the ELO algorithm to rank players according to. But this only works in zero sum games.
That's true. So the question we're asking, like, there is an algorithm, yes, but can we design a better algorithm? That's the question, right? So the entire goal of this, the rest of this session is just going to be about, can you ask more questions? It's not going to be to answer questions, right? So you'll not see any answers in the next 20 minutes or so. It's just going to be, we're going to ask so many more questions, and you'll decide, then you'll think about, oh, wait, why haven't I asked these questions, right? So that's the goal of the next 15-20 minutes. Okay. So what other factors should you take in? Which the team should win more matches, right? And the second factor I should take in is I should win against stronger teams, right? That is, if I win against India or Australia in test, that is something which is really considered to be a feat, right? Versus say winning against a team which does not so very well in the test. So that's something like, so winning against stronger teams is something which has to be taken given priority, right? Similarly, winning by higher margin. So for example, if say India wins by, I don't know, say 180 runs in an ODI game versus India winning by just say 2 or 3 runs, right? So this is something which has to be given a rather good amount of weightage, right? And next, this is something which is really not stressed upon, right? I'm not sure, like the last time I read, I heard that ICC does not consider away matches. So for example, if India is playing in say Firozshah Kotla, or maybe like in the Chidambaram Stadium, or Chidambaram Stadium in Chennai, Firozshah Kotla in Delhi, or maybe the Chinnaswamy Stadium in Bangalore, or Eden Gardens in Kolkata, they have some sort of an advantage, right? They have what is called the home turf advantage, right? That is something which is not taken into account. But let's say some Australians come and play in India. So instead of their Melbourne cricket ground, they're playing in Firozshah Kotla Chinnaswamy Stadium. So does Australia really have that advantage, that edge over other teams which play, right? So if they win in away matches, that is something which really has to be given weightage, right? Similarly, and you don't want to list that say Australia won a series of say, I don't know, 10 test matches in a row back in 1980, and so it is the best team. I don't want that happen, right? That would be ridiculous, right? So that is, I want my list to be as updated as possible, and I want to, in some sense, like make sure that everything is considered, right? But now, Firstly, many questions crop up here. First thing is, how do I give numbers to these? Winning more matches, can I quantify it, quote unquote? Winning by higher margins, can I quantify it, right? So once I quantify it, I'll just maybe add everything and say your total score is this much, and then I'll rank the teams based on the total score, and then finally I'll call it a day, right? But the question is, how do I add them? Can I give everything an equal weightage? Do I want to do that really? Because, for example, winning away matches, I want to give it slightly more weightage than winning more matches, right? Away matches, remember, like if they're not playing in their home country, I want to be able to give a little bit more weightage than winning more matches, right? So that is, I don't want to assign everything an equal weight. So if say this is converted into a number, I'll maybe multiply this by something like say 0.37, right? And I'll multiply this by say 0.45, right? And then I'll add and then call that to be the total score of the team. And based on the total score of the team, I'll rank the players, right? So this is something which I'll do. But how do we convert them into numbers, right? And how do we convert them into numbers, and how do you decide the weights? Right? That is, how do you decide that you have to multiply the first one by 0.37? How do you decide that you have to multiply this by 0.45? And these are many questions which crop up, right? And this is like a whole lot of things you can explore, right? And similarly, how do I rank players? So, for example, if you see the latest ICC rankings or things like that, they release a list of rankings, right? They have a list of batters and they have a list of bowlers, and they rank each of them. And they do it by some algorithm of theirs. But have you seen a ranking for fielders? Is there someone who, I mean, there are people like John T. Rhodes and maybe say Ravindra Jadeja who are fantastic fielders, but do they really appear on any ranking list, right? So Siri?
They were seen as all-rounders, sir.
I was just saying, sir, that no, there's nothing like fielders ranking.
Yes. That's sad, right? Fielders are a very essential part of the game, right? But why isn't there any ranking for fielders? Can we not design one?
Well, technically there is a ranking. There is a score for runs stopped, but I wouldn't exactly call that a ranking.
Yes.
Sir, we can also take it as how many catches they have.
Good. That's okay. Very good point. I'll come to all of your. I'd really like all of your suggestions. I'll come to all of your questions in a minute. Okay. So now, there are batters, there are bowlers, and there are fielders, right? And now, what is one? To rank batters, what can you do? You can compute their batting average, and that is the total number of runs scored by the total number of times they've got out, right? And a curious point here, why is it the total number of times they've got out and not the total number of innings they've played? Because I want to give an advantage to the people who are not out, right? So it's the total number of runs scored by the total number of times not out. So for example, if you see these uncapped IPL players who are playing their second game in the IPL, you'll see a star under their over their batting average. Star is that they've never been out, right? Okay. So what other things can I consider? So, let's come back to say it's raining heavily in Firozshah Kotla or maybe in Wankhede, right? It has been a very heavy rain and it will favor the bowlers, right? And I'm still ranking the batters, right? Do I really want to do that? Should I not give them some benefit of doubt to the batters as well for not favorable pitch, right? Similarly, if say someone is say they're facing say India's bowling attack or Australia's bowling attack, that is something which is scary, right? And I do want to give the batters an advantage. If they performed very well against say someone like Malinga's bowling or a very good bowler's bowling, I do want to give them credit for it, right? I can't say like say if I bowl versus if I become a cricketer and then I bowl, I should be treated in the same level as say I don't know Muthaiya Muralidharan or Malinga, right? So that is like the quality of the bowler they face. That is also something which has to be considered, correct? Similarly, what can I do for bowlers? For bowlers, things I can do are firstly, as someone pointed out, the number of wickets taken is definitely
economy, sir.
Yes, that's the very next point. Very good. right? How many runs have they given? The economy rate, right? So all these things I really have to consider in. And what other thing? Who was the batter who was dismissed, right? So for example, if someone dismisses, say, Glenn Maxwell or say Chris Gayle or Virat Kohli or people like these, then this is really adding a feather to the cap of the bowler, right? Versus if they dismiss me, then it's not really like something the bowler has to be proud of, right? So what does this call for? This calls for a unified ranking system, right? So if you see here, for batters, like the quality of the bowlers is also being used, and for bowlers, the quality of the batter is also being used, right? But what does ICC do? ICC ranks the two teams separately, or ICC ranks the two sets of players separately, right? So can I not, in some sense, unify all the players together so that there is like some mutual exchange also, right? So this is one question which has really been bugging my mind, right? And
Bowling better balls like Yorkers, sir.
Yes, that's a good option. That's a very good question. That's a very good suggestion. Yes. So how they place the balls? Yes. And if someone has, like, you have to penalize them if they put like 4 no balls in an over, right? You have to penalize them. They put 4 wides in an over.
Also, number of maidens.
Yes, very good answer. Yes, yeah, number of maidens. Very good. Yes, right. So all these things, these are some things which you really have to take into account, right? Now we have discussed it for batters. We have discussed it for bowlers. Now we again have to take some convex combination of this. That is, you have to assign some, say, 0.23 to this, some 0.15 to this, and 0.06 to this, right? But how do you decide the numbers? 0.23, 0.15, 0.06. How do you decide all these numbers? For that, you need to do some math, right? Now, coming back to this again, more important question: can you do the same thing for all-rounders? Can you do the same ranking system for fielders? Right? So, for example, can Ravindra Jadeja, who's a fantastic fielder, or say Hardik Pandya, who's a fantastic all-rounder, can these people be ranked somehow? Right? And
as all-rounders, sir.
Yes, as all-rounders. Is there a ranking for all-rounders?
Yes, sir.
Yes. So these are some.
By batting and bowling, sir. Seeing batting and bowling.
Yes, seeing both batting and bowling. But how much of batting and how much of bowling? All these questions we want to answer. Correct? How much of batting should you consider? How much of bowling should you consider? And these are some questions which we want to answer, correct? So for all these things, so for example, coming back to this example of Hardik Pandya, right? So he performs extremely well with both the bat and the ball, right? So, but how much of this should you consider, and how much of batting should you consider? How much of bowling should you consider? So these are questions like which has been puzzling us, right? So now what?
Seeing equal, sir. Okay, seeing equal of 3 balls.
Equal is a good suggestion, yes. But say someone like Virat Kohli, right? He does bowl also, but you don't want to give an equal weight to both his batting and bowling, right? You want to be able to give a higher weightage to his batting, because that is what he majorly does. So he does bowl.
We have to see the.
Yeah, we have to see. Sorry.
Yeah, we have to see which is their more stronger points. For all-rounders, there are batting all-rounders and there are bowling all-rounders. Correct. So like that, we try to.
Yes, that's a very good answer. Yes, so for each player, you have to treat them individually, right? So this is something like which calls for more math. That is, you need to be able to identify who's a batting all-rounder, who's a bowling all-rounder, and all sorts of things you need to be able to identify, right? So this calls for a lot more math implicated. Right? And okay, and I think I should mention this at this remark here. So I've called them batters. So I'm not sure if you've read the news lately. So ICC came up with like, this is something like which I'm really happy about. So like, to promote a more gender inclusive society, what they've asked for is there's no like batswoman now. So they're just going to be called batters, and this is something I think, like, which is a very good step in the right direction, where moving a society together as a whole. So let's from now on, like, agree to use batters instead of calling them batsmen, batswomen, and yeah. Okay. So now coming back to this question of Duckworth-Lewis method, right? This Duckworth-Lewis method, like I said, is like what is the par score that a team needs to score if the match is washed out by rain, right? So I just blindly point out to to this lecture. So it's called Mathematical Modeling in Sport by someone named Srinivas Bhogle. So he's a scientist at this data-driven institute. So he gives this fantastic talk as part of the Dayanand Sagar University in Bangalore. So do watch this talk, highly recommend it. He gives a fantastic explanation to how this Duckworth-Lewis method came up and like what are its pitfalls, what are the shortcomings of it, right? So in fact, he's the director of Chennai. He was the former director of Chennai Mathematical Institute, where I'm currently a student at. So he's Rajiva Karandikar. So these both are very, very close friends. So these both were classmates in their ISI Delhi days. And so these both have done extensive work on what is called the pressure index. Right? So pressure index, like maybe a very rough translation is the following. So when you're under pressure, so let's go back to yesterday's match. So RCB versus Delhi Capitals. RCB needed 15 runs of the last over, and what did KS Bharat? Yes, but they won. That's what I'm trying to highlight here, right? But they won. What happened yesterday? KS Bharat, a fantastic knock yesterday. I think 78 or something he scored, and a 6 off the last ball sealed the match, right? So like the general thing is that if you're under very heavy pressure, you tend to do slightly better. Right, that is like if you're that what I'm saying is that if the run scored under pressure is more valuable than the run scored when you're not under pressure, right? So this is something like which these both Karandikar and Srinivas Bhogle have very heavily worked on, and so in fact their entire family is into cricket. So Srinivas Bhogle's brother is Harsha Bhogle, the commentator. And so they've done like all sorts of works on these, and these both are again very heavily connected by their craze, I can call it, for Bollywood music. And Bollywood music is like ancient retro Bollywood music. And so yeah, okay. So for this DLS method, I'd highly encourage you to watch this Mathematical Modeling in Sport. So I'll put these slides up on my homepage, and all the links, most of the italicized fonts here are hyperlinked. So you can just click on it and you'll be directed to that. Okay. So now let's consider this very change of topic again. So this is very clever bet. Okay. Okay. Vinay, how long do I have more?
You have about 15 minutes. Yeah.
Okay. Great. Okay. So right. Okay. So let's consider this very nice bet. Okay. So there's something like I found out about this yesterday. Oh, and I found out only yesterday that the batting average is the total score by number of times they got out. Like only while preparing the slides, I realized that it's not the total number of innings they've played. Okay, so coming back to this. So okay, so there's a cricket match between India and Australia. Okay, so you need to have two smart friends for this. Okay, and preferably they shouldn't know each other. Okay. Let's say Madhu and Taylor are your two friends. Okay. Now, Madhu thinks that India is going to win with a 3/4 probability. Okay. And Taylor thinks that Australia is going to win with a 3/5 probability. Okay. You may want to note all of this nonsense, like there are many numbers, and it's anyways on the same slide, but it will be useful to have a pen handy. Okay. Now, you propose this bet with Madhu. Okay, you say you'll pay Madhu 80 rupees if India wins. Okay, and Madhu will pay you 100 rupees if India loses. Okay, similarly, you will pay Taylor 80 rupees if Australia wins, and Taylor will pay you 100 rupees if Australia loses. Okay, this is the entire setting. Okay, now what? Okay, so I hope this is clear. Any questions at the moment?
So could you just tell it again?
Sure. Yes. So the idea is, so there are two people, Madhu and Taylor. Okay, Madhu thinks that India will win with in a match between India and Australia. Madhu thinks that India will win with 3/4 probability, and Taylor thinks that Australia will win with 3/5 probability. Okay, that is, Madhu thinks that Australia will win with 1/4 probability, and Taylor thinks that India will win with 2/5 probability. Okay. Now you propose this bet to both Madhu and Taylor. Okay. You go and tell Madhu that if India wins, I'm going to give you 80 rupees. But if Australia wins, you have to give me 100 rupees. Okay. Similarly, you go and tell Taylor also that if Australia wins, then I'll give you 80 rupees. But if Australia loses, that is India wins, you have to give me 100 rupees. Right? Now, why do I need the friends to be smart? I need the friends to be smart because they need to fall for my trap. That is, they need to accept the bet. Right? Why will they accept the bet? Because 3/4 of the time, India is going to win, according to Madhu. Correct? So, 80 rupees she's going to get. And 1/4 of the time, India is going to lose, and they're going to get they're going to give 100. Right? And so, like ultimately, like Madhu expects 35 rupees. And similarly, if I do a similar calculation, let's not get into like why this details hold, but maybe just take it on faith for now. But think about it after the session ends. That Madhu can expect a 35 rupees total, and Taylor can expect a total of 8 rupees, right? So in probability.
Madhu has a profit, sir.
Yes, both Madhu and Taylor have a profit here, right? But now what I'm saying is you go and bet with both of them. Okay, make a bet with both. Let's see what happens. Any guesses? What will happen if you bet with both?
Get 100.
Sir, can I say?
Yeah, sure.
Then get 20 rupees.
Yes.
Yeah,
You're
sir.
making money out of two people's cleverness, right? Isn't that fantastic?
Yes.
Right. So if India wins, you're gonna get 20 rupees. Even if Australia wins, you're gonna get 20 rupees. So you're winning. Why don't you go and make this bet? Right? But we need Madhu and Taylor to be smart, right? And they shouldn't know each other. If they know that you're going to bet and you're going to give one person's money to the other, then you're going to fall into trouble, right? So the idea is no matter what, you have gained 20 rupees, right? So there are like all sorts of things like these which you can do in probability.
They are fighting, but we are enjoying, sir.
Yes. That's a very good way to say it. Yes, they're fighting and we're enjoying. That's nice.
The same goes for the banana problem in the beginning of the talk. Actually, if there's a spare piece of chocolate at home, and when my sister comes, I'm gonna do the bet with her.
Yes, tell all of us how it goes. I'm curious. Okay, and maybe in the interest of time, what I'll do is I'll skip the quotes part. But this is something like which I really want to do. So I'll put the slides for this part also. So I think this should be pretty self-explanatory, but nevertheless. So this is something which like I was really fascinated by the first time I came across this. So does anyone know him?
I don't know.
Okay, anybody? Okay, so the name is in the next slide. So do not Google him yet. Okay, let's play along with the fun. Yeah, Mehula, tell me how to pronounce your name again. It's horrible with this.
Yes, my name is Mehula, and I guess this person is Percy Diaconis.
Awesome. Yes. How do you know him? Do you want to say?
I just saw his picture in a book.
Ah, nice. Okay. Yes, this is Percy Diaconis, right? Okay. So let's see. Okay. So don't Google him as yet. Okay. This guy, he's a former magician, and he learned magic tricks by himself from the tender age of 5. Okay, and he left home and just with the goal of traveling with someone who's called Dai Vernon. So Dai Vernon is a very well-known magician, and so he wanted to just travel with Dai Vernon, right? And without the knowledge of his parents, or at least that's what I was told, he dropped out of high school, right? And he wanted to only read the William Feller's Introduction to Probability Theory and its application. So there's a classic book written a couple of decades ago, and like it's something like which really revolutionized the entire theory of discrete probability, right? So his only goal was to read this book and get a very good understanding of it, right? And what he did, so how did he earn? How did he support himself? He played poker on ships between New York and South America, right? And in the other times, he was gambling and playing in clubs, right? And what does he do now? He is now a professor of statistics and math at Stanford University. starting at such a humble beginning, ran away from home and started with magic tricks. He ended up just with probability theory. Like that was his first and only love, and just settled and did fantastic, exceptional work on areas around the probability theory, right? And this is something which really I found extremely shocking when I first read it, right? And so he studied a lot about randomness, right? So one of his major goals, so one thing which he can do is, so he came to CMI in October 2013. So there he gave a lecture in a packed seminar hall. So the seminar hall can, I think, seat about 75, 80 people. And there were people standing, and there were like, it was completely full, right? And so in fact, one of our director remarked that this is the first time he's seen the seminar hall so very full that there was not enough place to stand, right? So what he did is he tossed coins heads up 10 times in a row. And the reason he could do that is because he has studied coin flipping very extensively, right? So like he can control what the toss of the coin is going to be. That is, like if you like the force with which you flick it, or the position at which you flick it, and the temperature, air, throw all that into his head, and he'll tell you whether it's going to land in heads or land in tails, right? And so one of this very, very interesting story which he says is like he wanted to study how many times a coin flips in the air, right? So by counting the number of flips it undergoes, I can predict whether it's going to land in a head or land in a tail, right? So how do you study this? So what he does is he does a controlled experiment, right? So this controlled experiment, he controls the temperature, controls the pressure, and like controls where you flick the coin, controls with how much force you flick the coin. And what he studied is you put the coin in a long tube, okay? You flick it from the bottom, okay? Now, what you want to count is the number of times the coin turns in the air, right? What is one way of doing it? One way of doing it is to observe very keenly. But the coin, that's simply not practically feasible, right? It's going to turn very quickly, right? So what this genius did is he got an electron microscope. He rented an electron microscope. But the problem with that, as you can guess, is that it's too costly, right? Renting an electron microscope is not an easy task, right? So do you have any suggestions? How could we possibly count the number of times it turns?
Slow-mo camera?
Sorry?
A slow-mo camera.
Slow-mo camera, yes. So
camera.
take it back like 30 years earlier. Can we still do it?
No.
Yeah. So he did it 30 years earlier.
Sir,
What
seeing
other
in
suggestions?
slow motion, sir.
Oh, but okay. So how would you see it in slow motion? Just take a
Taking
regular
in camera, then seeing in slow motion. Can we
Okay,
count it?
good option. Okay.
Oh, he could take a normal video of it and play back the video very, very slowly.
Okay, that is a good option. But I don't have so much money. I can't buy a camera.
So,
What do I do?
Sir, he guesses the probability, sir.
Okay. Maybe yeah, Himani.
so he needs a good observer who can observe it very carefully.
Okay, that's a good answer.
Can
Yeah,
I-
Kirti. Yes.
He could try to find what's the time taken to make one flip, and then
Good.
take the whole timing and divide it by that.
Good answer. Okay, Harish.
Sir, you take into consideration how much force you flick it with and how much time it takes to do one flip, and how much distance it covers in one flip, and divide that distance by the length of the tube.
Good
That will give you
answer.
the number of flips it will.
Okay, good answer. Okay, maybe one final answer. Mehula. Are you around or? Okay. So what this genius, Percy Diaconus being the man he is, what he did is something which is like ridiculous. He do all of you know what a dental floss is?
Yeah, the thing you used to clean the stuff between your teeth.
Yes.
To clean your
He took that. Okay. He took a dental floss and tied it around the coin. Okay. Now you toss the coin. Okay. The dental floss is here. You toss the coin. Okay, the number of times it turns in the air, you can simply count it by unraveling the dental floss. Right? It's a tedious process, but it works. Right? Like 20 rupees, I can get one pack of dental floss and carry out the same experiment. Right? What a genius of an idea this is. Right?
But
now, oh, yeah.
How can it still how can the coin be still like when it spins? Is he sure that all the time when it flipped, the coin was properly on the dental floss?
Yes. So that you can ensure by like gluing it off. That is okay.
Okay.
Yeah. Okay. So this is like one genius of an experiment he did.
Can I ask a question?
Sure.
Do we need to take the consideration of atmospheric pressure while flipping the coin?
Yes, but let's say yes, we actually do need to, but let's just put it in a tube so that we can control the pressure. Right?
Okay, thank you.
Yeah. So this genius, he has been awarded all sorts of. He is a fellow of the American Math Society. He's a fellow of the National Academy of Sciences. He's a fellow of the American Philosophical Society, and he's won all sorts of awards. Right? And so this is a fantastic article by Quanta magazine. So where he talks about he is a mathematician in the literal sense, right? And so like a key takeaway from where did he start from? He started as a magician running away from home and doing all sorts of crazy things, and finally ended up as a professor at Stanford University, right? So like what is the biggest takeaway from him? Like for math, all you need is a very curious mind, and you need to have that perseverance and determination. So that's like one really very heavy takeaway from the life of Percy Diaconus. And so I think at this I'll rest my pen.
Aniruddhan, there is one raised hand. Do you want to take that?
Oh yes, sure. Megha, yes.
Megha.
Hi, I had a question. I just wanted to ask you, didn't the floss give any resistance to the coin?
Yes, the floss did, but see, like this is something like which can be controlled and can be something like which can be taken out of the experiment. That is, you add in some noise to the experiment, and you can remove it back later.
Okay,
that's a very good question.
Okay, thank you.
Yeah, Harish.
Yeah, can you please send the link that you had given in the first slide for the saying the PPT that you made in the chat, please?
Website. Yeah.
Oh yes. Okay. I'll maybe. Okay. It's not yet on my homepage. So once I put it on my homepage, it'll be there.
1 minute. I'll just copy it.
Yeah. Yes, I'll be sharing the. I'll put the slides on my homepage and. Yeah, Adrit.
Yes, sir. Sir, you said that Percy Diaconus flipped a coin over 10 times with only heads up. How are we to be sure that it was not a unfed coin?
Oh, so you can give him a coin, and he'll flip it. He'll make sure that it lands 10 times heads in a row.
Okay.
Are you convinced that the coin you have is not unfair?
Definitely not.
Yeah. Oh, okay. So in fact, I think I did not mention this. So I'm just trying to go to. Give me 1 minute. In fact, this is wonderful lecture he gave where he talks about these coin flipping experiments he does. So you can just check out this link as well. And like he gives a fantastic lecture. This is accessible to. I'm certain that is accessible to everyone here. So just check out this lecture also, and he talks like about his experiment in detail here. Yeah, Megha.
So for my doubt.
Yeah, 1 second. Yeah, Megha.
No, I'm sorry. It was a earlier hand. Yeah.
Oh, no problem. Okay. Yeah, Yuvraj.
So you told a device that he used to found how much times of coins it is tossed. Can you say what is that?
No, I'm not sure I got the question.
So you told a device, no sir, that is used to toss the coin and he found it.
Wait, Yuvraj, I'm not sure I understood the question. Maybe the voice is slightly breaking, or I'm
Sir,
not
can
sure.
you hear me?
Yes, I can. Yeah.
Yes, sir. Sir, you told no, sir, that he used something to toss the coin and found how much time it is cost.
Right. So, that's the power of his hands and his magic. Like, he can do it.
How can it be possible, sir?
Oh, that's a very good question. He talks about it in this lecture. In fact, like a little bit about like what he does and what goes on in his head. And rather, that would be a better way to play it. Yeah. Thanks again for the opportunity. And like one thing which I like really particularly enjoyed is like this fantastic set of questions and suggestions you people post. So, and this is like one thing which I wanted to remark. So maybe like Vinay, I'll just go on for one more minute here.
Sure.
Ask questions, like no matter what, just question everything around you, right? So remember, like this, take an example of this cricket, the whole cricket drama, right? So I did not answer anything. I just post questions that you could possibly think about, right? So question everything that is around you, and you'll see like a whole lot of math just comes up by just these questions. So for example, if you see something like this huge math thing called this Riemann hypothesis, that's a question essentially. Riemann was brave enough to ask, are something like, are all the roots in this critical strip, whatever that means, I have no idea, right? Are all the roots in that strip? That's a question he asked. So just keep your inquisitive minds on and question everything that is around you. And with that, I think like that's like one key takeaway that really should be from this talk. And once again, thanks very much for attending, and thanks a lot, Vinay, for the invitation.